Okay, this video is to review the homework number 4, 3, and 2. And we have already solved the homework number 1 in the classroom, so I won't review it here. And also this video is for the missed class on last Wednesday, right before the holiday. And the order of this review is gonna be homework number 4 first, and then homework number 3, and then homework number 2. So it's back ordered. All right, let's get started. Let me see how I can full screen. Okay. So homework number 4, the first question is, suppose that you plan to deposit a lump sum amount in your saving account at the beginning of your first year in college. So at the present time, you want to save some amount of money so that at the end of the 4th year, you can withdraw 1,000 every year for 5 years. Okay? If the interest rate is 3%, how much the lump amount you should deposit at the actually it's gonna be at the beginning, not at the end. That's a typo. So how much you should deposit at the beginning of the first year. So the problem is at the beginning, you want to save some amount so that in the end of the 4th year, you start to withdraw. Okay, withdraw 1,000 every year for 5 years. So you save at the time 0. So the first question is, what is the cash flow diagram is correct from your point of view. Okay, so first step is to draw the diagram. So at the beginning, you want to deposit some amount of money. So you have the money out of your pocket and save it in the bank account. So that's the money outcome. It's not income, it's outflow. So it's going to be arrow going downward. And that's the amount you want to solve for. So it's going to be dashed line. Okay, so, and it's also the value at present. So it's going to be P. You can also label it as P0, which means it's the amount of present value at the time 0. So, and then you hit the first year, 2nd year, 3rd year. Okay, you do nothing in the first 3 years. You just save the amount and then let the interest grow, okay? And then at the end of the 4th year, you start to withdraw. So every time you withdraw 1K, 1,000, and you withdraw, so no, you withdraw, so that's the money coming into your pocket. So it's arrow going up. And then it's 1K, okay? To save some space, we just use K for 1,000. And it said continue to withdraw 1,000 every year for 5 years. So you're gonna withdraw in the end of the 5th year, 1K. And in the end of the 6th year, the same thing. In the end of the 7th year, in the end of the 8th year. So you're gonna withdraw that continuously for 5 years. So starting from year 4, that's your first withdrawal, second withdrawal, 3rd, 4th, 5th, okay? So your timeline is from 0 to the end of the 8th year. So let's remove the additional length, okay? And the interest rate, okay, you can label it as 1K for every year. And then your interest rate is given as 3% per year. So the question is, what is the present value to make this cash flow? The first question is which cash flow is correct. So if you can draw this, you will know the answer, right? And then the second thing is you want to calculate the P0. And we said in the class that this cash flow is called deferred annuity. So the annuity is the original annuity problem is the cash flow starting at the beginning of the first year, and then it continue with the same amount for every year, and then that's our original annuity problem. And then the deferred annuity problem is the cash flow is not starting at the end of the first year. It starts at some time later. In this case, it starts at the end of the fourth year. So we're going to use the formula we introduced in the class. The formula for the deferred annuity So if you remember that, we said the formula is P0 equals to A, that's your deferred annuity, the amount of annuity. And then P/A, I% N minus J times another factor, P/F, I% and J. Okay, and we said it's very important to determine what is your J in this case. So in the deferred annuity case, the J is gonna be where you start the cash flow minus 1. So in this case, where you start the cash flow at year 4, okay? So your J is gonna be 4 minus 1, which is 3. That's how you find your J. Okay, so A is your annuity, which is 1,000 in our case. And P/A, I% is 3%, and in our case is 8, minus J is 3, right? And then P/F, 3%, and J is 3. So the next thing is to find the two factors in your interest table, okay? P/A, so you want to find the table of 3% and find the header P/A and find the row of n equals to 5. That's your first factor. And then you find the other factor in the same table, but under another column, P/F, and the row of n equals to 3. Okay, if you do that, you will find that the first factor is gonna be 4.5797, and the second factor is 0.9151, and then you're gonna have your final result, which is 4190.88. Okay, so that's the first question, first problem. Okay, let's continue. The second problem is, okay, if your credit card APR, which is the nominal interest rate, is 8%, but it's compounded monthly, okay? It's compounded monthly, not yearly. Then find the effective annual interest rate. So we introduced that formula, right? And that formula is here. So the first question is, according to the problem statement, what is the interest per month? Okay, your APR is 8% per year. Okay, if you know 8% per year, then how many percent per month? How do you do that? So it's gonna be 8% divided by 12, right? So the answer is 0.667%. The second question is to find the effective annual interest rate. The formula to be used is this formula, okay? What are the correct value for R and M? And R, what is R? In the class, we said R is the nominal interest rate. So R is 8%. And M is number of interest period per year. So we said it's compounded monthly. So every month you're gonna compound the interest. So in a year, you're gonna compound how many times? So M is 12, because in a year you have 12 months, which means you have to compound it 12 times. So number of interest period is 12. And the next question, what is the effective annual interest rate? So now it's very easy. You just use this formula, I equals to 1 plus R over M, okay, to the power of M minus 1. And in our case, R is 8%, M is 12 to the power of 12 minus 1. It's gonna be 8.3%. That's it. Okay, and then let's move on to homework number 3. Okay. First problem, calculate the interest earned by saving. So you're gonna calculate the interest. Okay? Interest earned by saving 9,000 for 5 years at 8%. Simple interest rate. You remember that simple interest rate? Interest, the amount of interest is always the same. It's always based on your principal. That's your simple interest rate, okay? To solve this problem, what formula do you want to use? Simple interest rate problem we introduced in the class, it's very easy. I equals to P times N times I. P is your principal. N is number of interest periods, and I is your interest per period. And so in our case, what is P? Principal is, that's the original amount, okay? It's 9,000. And N, we said you wanna save that amount for 5 years, so N is 5. And interest rate per year is 8%. So how much interest you can earn? You just substitute the letters in the formula by those numbers. So and P times N times I. And your answer is 3,600. Then the next question is, what is the total amount of money you have in your saving account at the end of the 5th year? So in the end, in your account, you have not only your principal but also the interest. That's your total amount. So total will be your principal plus interest, right? So principal is 9,000, interest is 3,600. So your total is 12,600. Okay. Next question. calculate the interest you earn by saving 9,000 for 5 years at 8%, but compounded annually. So you're not doing the simple interest rate, you're doing the compounded interest rate. So compounded interest rate is based on every time based on the principal plus the previous interest. That's the difference between the compounding interest and the simple interest. So to solve this problem, we also introduced our formula for compounded interest, which is I equals to P times 1 plus I to the power of n minus P. Okay, and in this case, you want to know what is P. P is principal. It's 9,000. And I is interest rate. It's 8%. N is 5. So your interest is n equals to 9,000 times 1 plus 8% to the power of n minus 9,000. And if you calculate this, you can have your interest as 4,223.95. Okay, but the other question is, what is the total you have in your saving account? And we said total amount is your principal plus the interest. Your principal is 9,000. Your interest is 4,223.95. So your total amount is 13,223.95. Okay. If you take a look at the previous problem, okay, you save the same amount, you have the same length of the time, you have the same interest rate, but because it's a simple interest rate problem, so in the end you have 12,600. That's less than this 13,223.95. Okay, so which interest you want to have? You want to have the compounded interest rate, because every time it's based on your principal plus the previous interest. So you're growing bigger and bigger. And the next question is to calculate interest earned by saving 9,000 for 5 years at an annual interest rate 8%, but compounded quarterly. Okay, that's the tricky part. Compounded quarterly, which means your interest period is a quarter. Okay, it's not a year. So you have to do some conversion about the interest rate per period, because every time in the formulas, the interest rate you want to use is the interest per interest period, not just the annual interest or the nominal interest you're given. Okay, so that's the tricky part of this class. So the first thing is what formula to use. So it's although it's compounded quarterly, it's still a compounded interest rate problem. So the formula is the same. It's I equals to P times 1 plus I% to the power of n minus P. Okay, and your P is still 9,000. But your I% per period is 8% over 4. Why? Because 8% is annual interest rate. It's an interest rate for a whole year. But because your interest period is a quarter, so every quarter, how many percent you got? 8% divided by 4, because in a year you have 4 quarters. That's how you get this new interest period as 2%. And your number of period, N is number of periods, not just number of years, okay? It could change. It could be number of months, number of quarters, number of days, depending on what is your interest period. And here, our interest period is a quarter, okay? So your N is 5 times how many quarter a year? 4. So your N is 20. And then let's use the formula. 9,000 times 1 plus 2% over 20 to the power of 20 minus 9,000. You see the difference, right? So your answer is gonna be 4,373.53. That's your interest. And your total now is 9,000 plus 4,373.53. So it's 13,373.53. Okay? Move on to the next one. All right, so the new problem, Tom wants to invest his money in a stock market. He's interested in one stock which could yield an interest rate of 5% annually. Okay? If Tom invests 10,000 at present for 6 years, how much in total he can get back at the end of the 6th year? The future equivalent of the 10,000 after 6 years. So, to solve the problem, what is the correct cash flow diagram? Cash flow diagram problem. Okay, so now we want to draw this from Tom's point of view. So Tom spent 10,000 at time 0, okay? He spent 10,000, so that's gonna be going downward. And it's P, right? And it's 10,000. And it said year 1, year 2, year 3, year 4, year 5, year 6, okay? At the end of the year 6, he want to sell that stock and he will have some income. So what is the income in total? Because it's unknown, so it's dashed line and it's a future amount. We want to know. You can label it as F6 because you will know that's gonna be some future value at times in the end of year 6. Just easier to understand what is the timeline, okay? So that's your interest rate here is 5% per year. All right, so this is your cash flow diagram. And the question, what is the future value of that 10,000 present? So we have a formula for that, right? It's F equals to P times 1 plus I% to the power of n. And if you substitute all the letters with the numbers, it's gonna be 10,000, 1 plus 5% to the power of 6. And your answer is gonna be 13,400.96. Okay, and the next question is, okay, if you want to use the factor method instead of this formula method, what factor you want to use? Because now you are given P to find F, so the factor is gonna be F slash P. I equals to 5% and N is 6. So that's your factor. And the value of the factor is, you have to check your interest table, and you want to find the table of 5% first, and then you want to have the header of F slash P, and you want to locate the row of N equals to 6. And then you are going to find that in that factor, which is 1.3401. Okay. Next question. Suppose you contribute $10 per week. Okay. Per week, which means for a year you're gonna have 520 as a saving. Okay? Because every year you have 52 weeks. So every week you contribute $10. For a year you contribute 10 times 52. That's how you have this 520 per year. So you're contributing this amount every year, and at an interest rate of 6% a year, and it's compounded once per year. Okay, that's probably one less pizza per week, right? It's $10 a week. That's very little. But if you contribute faithfully each week into this account, how much money would you have saved through this compounding of interest by the end of year 15? Okay, so this is to let you see the power of the compounding interest. All right, and based on the problem, what's the statement described? What kind of question it is? Well, it's a question of, okay, for every year you're gonna save or contribute the same amount, and you're gonna do the same thing repeatedly for 15 years, and then you want to know in the end of that 15 years how much you can have. So it's an annuity problem, right? Annuity problem is the same amount of cash flow happening or occurring every interest period. So basically this question is about to find the equivalent future value of an annuity. And if you use the factor method to solve this problem, which formula is correct? Okay, what is the formula using the factor method? Because you're finding the future value given A, so your F is something you want to know. And it's based on annuity, so it's A times a factor. It's to find F given A at the interest rate 6% for how many years? 15 years. Okay, so that's your factor. And in our original question, the generic writing of this factor is gonna be this. Okay? And now you want to know what is A, what is I, what is N. Well, I is 6%, N is 15, A is 520. Because we're talking about compounding 6% every year. So your annuity is gonna be yearly annuity, and it's gonna be 520. So how much exactly you can have at the end of the 15 years? You just substitute the letters with these numbers. So it's 520 times f slash a 6% 15. And you want to check your interest table to find the table of 6% and the header of f slash a and the row of n equals to 15, and then you're gonna find your factor as 23.2760, and your answer is gonna be 12,103.52. Okay. Now let's move on to homework number 2. Homework number 2, the first question is, you purchased an equipment in year 2006 for 30,000. Okay, so your cost in year 2006 is given as 30,000. Okay, but you have to replace this equipment by a new one in late 2017. Okay, so that is year, and we're gonna have a new time, 2017. What is the estimated cost of the replacement equipment? So you want to know what is the cost in year 2017 based on the following cost indices. Okay, this is our indexing problem. So this is a method. Did you remember the indexing method is to estimate your future cost of something you have purchased or something you already know the price in a historical time point. So in our case, you know the price of the equipment in year 2006 is 30,000. And then you also know the index of this equipment in different years. You see that? From 2004 to 2017. So you know the index, and then you know the historical price. So now you want to estimate the future price. Okay, you remember that formula? We introduced the formula Cn equals to Ck times In bar over Ik bar. Okay, and we said this is your unknown price, and this is your given price. Okay, and you want to keep the C and In both above that bar. You don't want to write it as Ik bar over Im bar times Ck, right? That's something you have to avoid. Okay, this is wrong. So the position of the Cn, Ck, In, Ik is very important. And to solve for this problem, you want to know C 2017, right? And you are given C 2006. So the two indices you want to use is for the unknown year 2017, the index, and for the given the price when the price is known, the year 2006, the index. So that's the two indices you want to know. And you want to look at this problem statement to find the value of these indices. So C 2006, we already know that it's 30,000. And index 2017, what is that? It's this, right? So it's 265. and your index in 2006 is this 149. So your C 2017 is gonna be 30,000 times 265 over 149, which is 53355.7. So that is your estimated price for the same equipment in the year 2017. The next question. Okay, so the next question is about a piece of land for a warehouse. Okay. So the question is for a 20,000 square foot warehouse. The price for the construction is 800,000. And if the cost capacity factor is 0.83, what is the estimated cost to construct a similar warehouse but in a larger size, which is 30,000 square foot? To solve this kind of problem, well, you know the cost capacity factor and you know the different sizes, and then you know the price of one of the size. The method is called power sizing. Okay, so and we have introduced the formula as CA equals to CB. CA is the cost of project A, CB is the cost of project B, and C and B is very similar in many natures, but it's just different size. Okay, and if you know the cost of one size, which is the size of B, and you can estimate the cost of another size of that project, which is CA. So the formula is CA equals to CB times SA, the size of A, over the size of project B to the power of X. Okay, and here in the formula, the X is the factor, cost capacity factor. So your CA is something you want to know. Your CB is given, which is, well, CB is gonna be the cost of the 20,000 square foot warehouse. So CB is 800,000. And SA is the one you don't know, which is in our case 30,000 square foot. And SB is the size of the warehouse. You already know the price. It's the 20,000 square foot. And your X is 0.83. So your CA in our case is the house, the project of, or the warehouse of 30,000 square foot equals to C of the 20,000 square foot times the ratio of size 30,000 over 20,000 to the power of 0.83. 30,000 is the size of the warehouse, the larger warehouse. The 20,000 is the size of the smaller warehouse, okay? And you substitute the letters by the values. It's gonna be 800,000 times 30,000 over 20,000 to the power of 0.83. Your answer for the estimated price of the larger warehouse is going to be 1120071.46. Okay. Then the next question. The time to assemble the first unit on the production line is 10 hours. So first unit, 10 hours. The learning rate is 0.9. Approximately how long will it take for the 6th unit to be assembled? So obviously this is a learning curve problem, right? And for the learning curve problem, we introduced the formula ZU, that is the time cost for the youth unit, equals to K, that's the time cost for the first unit, times U to the power of N. And here we said N equals to log learning rate over log 2. Okay, so S is learning rate. We said this is a set of formulas, so you have to do both. Okay, and based on the statement, we know the time cost for the first unit, K, is 10 hours. Okay, and then the unit you want to solve for, you want to know the time cost for the 6th. So your U is 6. And your N is log learning rate. In our case, learning rate is 0.9, so 0.9 over log 2. And you want to use this formula. So ZU equals to 10 times 6 to the power of log 0.9 over log 2. And the final result is 7.6 hours. So the time cost to produce the 6th unit is 7.6 hours. Alright, that's all for this video.